Okay, class. So I'm going to go over the answers for the textbook pages today. So I'm going to go back over after I go over all the answers. I'm going to show you guys how I would do number one. The answer to number one is 27. Number two is 64. Number three is 3 and 3/8 inches cubed. So we get that by multiplying length times width times height. Number four is 233 and 1/10. If you look down here, number seven is 11 and 1/4. Number eight is 17 and 7/9. Also, guys, make sure you're writing the proper units, right? These are square cubic units because it's volume. Volume is always in cubic units. So 17 and 7/9 cubic yards. Number nine is 31 and 2/10 cubic meters. And lastly, number 10 is 1 and 512 thousandths meters cubed. Okay, so if we look on to the next page, all right, this is just like those three problems from the last topic where you have to solve for the variable inverse operation. So if you remember, it is volume equals base times height. So what I would do is I would set that up as an equation. I would divide both sides by 8 3/4. All right, so that may be a little bit challenging, right? Because you have to make them improper fractions and then divide. That problem's actually a lot of work. The answer ends up being 8.5 inches. All right, so if you look at number 12, you have to first multiply 2 and 2/3 by 4 and 2/3, and then divide 84 by that product. 13, same thing, multiply both sides by, multiply 11.5 times 4.5, and then divide 357 and 75 hundredths by that product. Okay? All right, so now let's look below, number 14. So number 14 is saying 1/2 inch edges. So this is kind of like numbers 1 and 2, right? So we tried to figure out how many like 1/3 inch cubes can fit into it. So a 1/2 inch cube can fit into 7.5 evenly. So if we look at box A, right, it can fit into 7.5 evenly. All right, but a 1/2 inch and a 1/2 inch cube can fit into 2 inches, and a 1/2 inch cube can fit into 11.5 inches evenly. Then if you look at box B, it can fit into 9 inches evenly, but it cannot fit into 2 and 1/4 inches evenly. So a 1/2 inch cube cannot fit along the width of box B. It can along the height though. So if you look down here, this is how the textbook worded it. So if you want to see how they worded it. All right, so now let's look at number 15. So it says, how much greater is the volume of the box with the greater volume than the volume of the box with the lesser volume? So if we scroll down here, we can look at the answer for number 15. So for box A, the volume is 172.5 inches cubed. Box B is 172 and 1/8 inches cubed. Okay, so the volume of box A is 3/8 inches cubed greater, right? Not by a lot, just by a little bit. And that's because a half is bigger than 1/8 by 3/8 of an inch. Okay, so now let's look at number 16. So 16, we have to find the volume of the gold bar, length times width times height, and we get 44 and 13/32 inches cubed. Number 17, how many 1/4 inch cubes will fill this prism? So this is like the first problem. So you have to find out how many 1/4 inch cubes fit along the length, how many 1/4 inch cubes fit along the width, and along the height. So think about it, there's 4 1/4 inches in 1 inch. So 4, 8, 12, 16. So that means there's 16 1/4 inches that fit along here. Okay, along here, there is 4 plus 3, so that's 7. And along the height, that is going to be 8 plus 2, which is 10. So, and I'm going to show you, again, how that problem will kind of look with the first couple. The answer to number 18 is D. All right, so let me just move this out of the way. So the first problem, so if you look at number 1, it says a third inch cube. So let's just say, let me move this out a little bit. Okay, so let's say we have a cube right here. Okay, they want to know how many third inch cubes can fit into this 1 inch cube. So that's 1 inch by 1 inch by 1 inch. So if we have cubes, right, a third inch cube, there would be 3 1/3 inch cubes that can fit along the length right here. Okay, and also 1/3, 1/3, 1/3. There's 3 that can fit along the width, and along the height, there are another 3. So there are 3 that can fit along the length, the width, and the height. So the way to find the volume is to basically just multiply length times width times height. So 3 times 3 times 3. So there are going to be 3 times 3 is 9 times another 3 is 27. Okay, 1/3 inch cubes that can fit into a 1 inch cube. Okay, let me also just quickly go over that last question, number 18, with you guys. So let me just erase this. Try to draw a quick sketch. So it says the length is 4 inches. The width is 1 3/4 inches and 2.5 inches. So they want to know, well, how many 1/4 inch cubes can fit into this length? So 4 inches. So think about it. There's 4 inches. And in each inch, we can fit 4 1/4 inches. So 4 1/4 inches, 4 1/4 inches, 4 1/4 inches. So that means that each one of these is a 1/4 inch. Okay, there will be 16 1/4 inches that can fit into 1 inch. So along the width, right, there's 4 in 1 inch, 4 quarters can fit into 1 inch, and then there's 3/4. So that's a total of 7. Then here, there's 2. There's 4 in each inch, and there's 2 quarters that can fit into a half. Okay, so that would be 10. So to find the answer to this question, I do 16 times 7 times 10. Right, and that's how I found the answer, which was 1,120. That's how many 1/4 inch cubes can fit into this, this figure. So hopefully this helps, guys. If you have any other questions, make sure that you send me an email or post it. And if necessary, I'll post another video, maybe trying to go over whatever it is you may need help with. All right, guys. Have a good rest of your day.